Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad RAZIQ bin Zamrus and my metric number is B1325107332.
Assalamualaikum, my name is Muhammad FARIS bin Faizal. My number matric is B13251073.
And today, I'm going to present about analysis and design of Pratt Truss. On this slide, we can see the objectives of our project. First, we aim to construct a complete free body diagram based on the given Pratt Truss structure. Next, we formulate the equilibrium equations needed for the analysis. We also determine the internal forces acting on each truss member and identify whether they are in tensions or compression. Finally, we evaluate the structural behavior and stress distribution under the applied loading condition. Alright, now let's move on to introduction. A Pratt truss is a structural system made up of interconnected members that transfer load through tension and compression. It is commonly used in bridge construction because of its efficient load distribution. In this project, we analyzed a Pratt truss bridge with a span of 24 meters and a height of 3 meters. The bridge is subjected to two concentrated loads, which are 200 kilonewtons at joint C and 220 kilonewtons at joint E. The analysis focuses on determining support reaction, internal member forces, and selecting the critical member for material comparison. So for the problem statement, this slide shows the given Pratt truss structure and the requirement of the assignment. The bridge is supported by a pin support at joint A and a roller support at joint G. The applied loads are P1 equal to 210 kilonewtons and P2 equal to 220 kilonewtons. Our tasks include calculating support reaction, determining internal member forces, identifying the critical member, and comparing the suitability of A36 carbon steel and A572 high strength steel for the design. Alright, for this slide, the first step in the analysis is to determine the support reaction using static equilibrium equation. By taking moment about point A and applying the sum of vertical forces equal to 0, we obtain the reaction forces. The results show that the horizontal reaction at A is 0 kilonewton, while the vertical reaction are 213 and 33 kilonewtons at A and 216 and 76 kilonewtons at G. This value are then used for the analysis of the truss members. Alright, so for the internal member, after calculating the support reaction, we use the method of joints to determine the internal forces. At joint A, member AH carries 267 kilonewtons in compression, while member AB carries 160 kilonewtons in tension. At joint B, member BH is identified as a zero force member and member BC carries 160 kilonewtons in tension. These results indicate how the load is transferred through the structure. Internal member forces, joint H and joint C. Next, we analyze joint H and joint C. At joint H, member HC experiences 267 kilonewtons in tensions, while member HI experiences 320 kilonewtons in compression. At joint C, member CI carries a small compressive force of 3.33 kilonewtons, whereas member CD carries 320 kilonewtons in tension. These results show that member CD is one of the highly loaded members in the truss. Alright, for internal member forces, joint I and joint G. For joint I, Member ID carries 4.17 kilonewtons in tension, and member IJ carries 322.50 kilonewtons in compression. At joint G, member GL experiences 270.83 kilonewtons in compression, while member GF carries 162.50 kilonewtons in tension. The analysis of these joints helps us continue identifying the force distribution and determine the critical members of the structure.
I will continue explain about this solution. At point F, outward positive Fy equals 0, Fl equals 0 kN, which means is 0 force. Then leftward positive Fx, Fe minus Fg, Fe minus 162.5 equals 0. Then final answer is Fe equal 162.5, which means is tension. Then the next is at point L, downward positive Fy equals 0, Lg times 4/5 plus Lf plus Le times 4/5 equals 0. Negative 270.83 times 4/5 plus 0 plus Le times 4/5 equals 0. Negative 216.67 plus Le times 4/5 equals 0. And final answer, Le equal 270.83 kN, which means is tension. Then we go to find the Fx, which means is leftward and positive. Lk plus Le times 3/5 minus Lg times 3/5 equals 0. Lk plus 270.83 times 3/5 minus negative 270.83 times 3/5 equals 0. And the final answer is Lk equal negative 325.00 kN, which means is compression. The next is at point E. Upward positive Fy equals 0, Ek plus El times 4/5 minus P2 equals 0. Ek plus 270.83 times 4/5 minus 220 equals 0. Ek plus 216.67 minus 220 equals 0. And the final answer is Ek equal 3.33 kN tension. And the next, leftward positive Fx equals 0. Ed minus Fe minus El times 3/5 equals 0. Ed minus 162.5 minus 270.83 times 3/5 equals 0. Ed with 325.00 kN, which means is tension. And the next at point K, downward positive Fy equals 0, Ke plus Kd times 4/5 equals 0, and 3.33 plus Kd times 4/5 equals 0. And the final answer for Kd is equal negative 4.17 kN, which means is compression. And the next, leftward positive Fx equals 0, Kj plus Kd times 3/5 minus Kl equals 0, Kj plus negative 4.17 times 3/5 minus negative 325.00 equals 0. And the final answer for Kj is 322.5 kN, which means is compression. And the last, at point D, upward positive Fy equals 0, dk times 4/5 plus di times 4/5 plus dj equals 0. Negative 4.17 times 4/5 plus 4.17 times 4/5 plus dj equals 0. Negative 3.33 plus 3.33 plus dj equals 0. And the final answer for dj is 0, which means is 0 force. And the next question is identify the member experiencing the maximum absolute force, which means critical member. And the answer is ED equal 325.00 kN, which means is tension, and LK equal 325.00 kN, which means is compression. The next is question 4. Table 1 shows the structural steel alloys, and the question 1 is compare the minimum cross-sectional area using both material with factor if safety equal 2.0 set against yielding. And the question 2 is determine the elongation of critical members. Then do the solution is A36 carbon steel, stress Y equal 250 MPa, and stress allow equal 250 per 2 equal 125 MPa. Using the stress and strain formula, stress equal F per A, which means A equal F per stress allow equal 325,000 per 125 equal A equal 2600 millimeter square. Then do the A572 high strength steel. Stress Y equal 345 MPa and stress allow equal 345 per 2 equal 172.5 MPa. And the final answer A equal 325,000 per 172.5, and the last answer is A equal 1884.06 millimeter square. Then the last is to find elongation of critical member. Modulus of elasticity, which means symbol E. EA36 equal 200 GPa and EA572 equal 200 GPa. F equal 325,000 N and L equal 3000 mm. And for A36 carbon steel, using axial deformation, 325,000 times 3000 per 2600 times 200,000, and the final answer is 1.875 mm. And for A572 high strength steel, using axial deformation, 325,000 times 3000 per 1884.06 times 200,000, and the final answer is 2.587 mm. And the last is conclusion. The analysis of the Pratt's bridge successfully determined the support reactions, internal member force, and critical members under the applied loads of 210 kN and 220 kN. Members ED and LK were identified as the critical members with the highest force of 325.0 kN. The comparison show that A572 high strength steel requires a small cross-sectional area 1884.06 mm square than A36 carbon steel 2600 mm square, while A36 carbon steel experience lower elongation 1.875 mm compared to A572 height strength steel 2.587 mm. Therefore, both materials are suitable for the structure, with A572 offering better material efficiency and A36 providing greater resistance to deformation. Thank you.